Hello everybody, let's do some examples dealing with logarithms of the base 10 and evaluating those things. So, we're going to set, the first question is, well, just find the common logarithm using a calculator. So when we say find the common logarithm, we're interested in finding a logarithm base 10. So we're interested in finding the logarithm 0.0640, right? Whatever that decimal is. Well, I have to get my calculator out to do this, so I'll go ahead and get my calculator here. And I'm going to put in 0.064. Let me straighten that out. 0.640. And I'm going to take my logarithm. So in my setup right here, I have a logarithm right here. Here it is. So I'm going to use log, the common logarithm of that number. And you notice I get negative 1.1938. I'm going to carry it out a few digits right here. So negative 1.1938. Negative 1, oh, get my pen here. Negative 1 point, I got to look again here. 1938. Good Lord, I'm not very good at this. Point 1938. Okay, so that's my decimal. Now how about this one? This one looks a little bit harder. And you can actually put this into your calculator if you care to this way. But I'll tell you, really the only logarithm you're going to need to take is this first number. It's called an abscissa. We're going to take this logarithm of 8.043 times 10 to the negative 8th and save yourself a little bit of time. What it's really equivalent to writing is by our addition rule. Remember, we talked about this. It says that if you take a logarithm of a times b, remember this? That's the same thing as taking the logarithm of a plus the logarithm of b. So if we think about this, we're going to be taking the logarithm of 8.043 plus the logarithm of 10 to the negative 8th. Okay. Now, here's the thing. This logarithm right here, this logarithm of 10 to the negative 8th, we also have another rule that tells us anytime you take a logarithm, a common logarithm of some number to the n power, then we can just take that n power in front and just treat the logarithm of whatever follows right here. Well, in this case right here, that's supposed to be a 10. That didn't come out very well. Just trust me. In this case, that means we're going to be taking negative 8 times the common logarithm of 10. What is the common logarithm of 10? Well, we're asking to what power must we raise the base 10 to get 10? The answer is 1. So this second value right here is going to be negative 8. So we're going to be adding negative 8 to whatever we get from the logarithm of 8.043. So we don't even need to calculate anything out right here. Let's just go ahead and get that logarithm of 8.043. So I'm going to take 8.043 and I'm going to take my logarithm. Boom, there it is. 0.9054. 0.9054. 0.9054. And remember, this says subtract 8 from that number, so let's go ahead and subtract 8 from that number. Boom. Negative 7.0946, pardon me. Negative 7.0946. Negative 7.0496. There's our number. That's what we were interested in. And so this is going to be our logarithm. How about these anti-logarithms? Well, when we say an anti-logarithm, remember we defined an anti-logarithm to be the exponent version of this. So what we're really asking you is we're asking to find 10 raised to the 0.9292. Again, this is a job for a calculator. We're going to get 0. Oh boy, I better look at the number here. I should really have these things written down. 9292. 0.9292. 0.9292 2. And this time I'm going to use my 10 to the x to get that. So here it is, 10 to the x. And I get 8.4957. 8.4957. So this is 8.4957, right? Same idea right here. We're going to have 10 to the negative 6.9788. So in my calculator, we're going to have negative, good Lord, negative 6.9788. Uh, 6.9788, we want the negative of that, and we're going to take 10 to the x of that one. Ooh, look at this one. We get a nice scientific number, which is the same thing as saying 1.05 times 10 to the negative 7th. 1.05 is equal to 1.05 times 10 to the negative 7th. All right, so this is about what we would expect right here. Okay, we can use a log of calculator to verify this, and I implore you to do so. Take the logarithm, the common logarithm of 500, subtract the common logarithm of 20, and then take the common logarithm of 25. If you subtract these two numbers, you should find that it's equal to the logarithm of 25. Now, why is that? Well, if you remember our other rule for logarithm, it says that if we have a logarithm of the subtraction, it's the same thing as dividing the two arguments together in a single logarithm. And if you take 20 and you divide it into 500, you get, well, lo and behold, 25. So this is really the same thing as saying the logarithm of 25, and they should be equal. And this is a good verification of that rule. Okay, more examples to come.